No, Elizabeth? She's there? Nice that you're there, Elizabeth. Let me be writing the problem up here. We want to express this ratio, or this fraction, 2/3, in two different ways, or you can look at this and see that we can write three different ways for each of these numbers. So this is how the ratio 2/3 is written as expressed as a fraction. We want to know what to write it as a decimal, and we were given the expression 66 2/3%, which is the percent equivalent of 2/3. So what we want to do tonight to begin this one is to find out what would be the decimal representation of the fraction 2/3 or of the percent 66 2/3. Are you ready yet, Elizabeth?
Yeah.
Okay, good. So what do we need to do to find a decimal here when we know the fraction and we know the percent? We've got a couple of choices. Do you have a preference which way we go? No? Okay, probably the easiest way to do this one, because we've got a percent that has a fraction onto it, the easiest way to find the decimal would probably be to go with this one and turn the fraction into a decimal. And to turn a fraction into a decimal, what we do is divide the denominator into the numerator. So let's go ahead and do that. We want to divide 3 into 2, and the instructions on this problem tell us to write the decimal equivalents correct to the nearest thousandth, okay? So let's go ahead and begin this one. We can bring the decimal straight up. Now, 3 will go into 2 how many times?
I don't know.
Okay, it doesn't go, okay? 3 won't go into 2, so we can put a 0 over here. How many times will 3 go into 20? Are you there, Elizabeth? 3 will go into 20. Let's try 6, okay? We subtract. We've got a remainder. We can bring down another 0. 3 again will go into 20 6 times. And we can see that what we've got here is a repeating decimal. And because we know that we want to round this to the nearest thousandth, we want to go one past the thousandth position. So here's the thousandth position right here. We look at the number just to the right of it, and we see that this number is 5 or more. And whenever we have a number that's 5 or more, we raise the one that we're rounding to 1 by 1. So since this is a 6, we're going to raise this one by 1. So the decimal equivalent of 2/3 would be 0.667. That is correct to the nearest thousandth. So Elizabeth, we appreciate your call and hope that was helpful to you. Let me slide over here now and let you take a look. This was yesterday's brain teaser problem. It said to find a familiar 7-digit number whose digits add up to 25. And of course, the number was our phone number, 7521811. Now, we're going to start out with a brain teaser question tonight, maybe as a little bonus to those of you who watched from the beginning. So let's start out with the brain teaser being this. What is the prime factorization of 7521811? So we're taking this number. It would actually be 7,521,811. Now, let me give you a couple of pointers here. First of all, let me tell you what a prime factorization is if you've forgotten that. To write the prime factorization of a number, we just take the number and find what factors will go into it. Maybe writing an example would be the best way to explain it. If we took the number 20, we can factor 20 into 2 times 10. Now 2 is a prime number, but 10 is not a prime number. So we would need to split the 10 up. And if we split the 10, we could split the 10 into 2 times 5. So the prime factorization of 20 would be 2 times 2 times 5. Okay? So we want you to find the prime factorization of this number. I will tell you that it is not prime. So there are some factors involved, but I will also tell you that it's not going to be a very easy problem. But you've got an hour to figure it out. And if nobody is called in with the correct answer by around 5:40 or so, then we'll possibly come up with another brain teaser. So go ahead and see if you can figure that one out. Write the prime factorization of that number. We'll go over now to Mrs. Pullman for the next problem.
Okay. I have a problem from the 7th grade pre-algebra. Those of you that are working on your 4, on the section where you're dividing with mixed numbers. We have a division and a multiplication problem mixed together here. We are going to work what's inside the first parentheses first. We have 5 1/16 divided by 6 3/4. Before we can do that division, we need to convert those to fractions. So we go 16 times 5 and figure out what that is. I'll work it out over here on the side. 16 times 5 is 30. Carry the 3, 5, and 3 is 80. So it looks like 16 times 5 is 80 plus 1 makes that 81/16. Then it says divided by 6 3/4. So we go 4 times 6 is 24 plus 3 is 27/4. Okay, that's still inside the parentheses, and we're going to come back and do that. Right now I'm going to come over and change this mixed number into a fraction also. 9 times 7 is 63, plus 5 is 68, so we come up with 68/9. And of course that would be negative since the number up here was negative. Okay, to divide by a fraction, you'll remember that we multiply by the reciprocal. So we take 81/16 and we multiply by the reciprocal of 27/4. The reciprocal would be, just turn it upside down, and it's 4/27. The other part of our problem was multiplying it by a negative 68/9. Now I'm going to do as much simplifying as I possibly can, but before I do that, I want to check and see what my answer would be, if it would be positive or negative. The first number is positive, the second number is positive, and the last one's negative. So my answer would be negative. You could think of it this way: a positive times a positive is positive. A positive times a negative number gives us a negative answer. Now that I've decided what sign my answer will be, I'm going to go ahead and simplify these fractions. For instance, 4 goes into 4 once, and it goes into 16 4 times. Let's see, 27 goes into 27 once, and it goes into 81 3 times. 3 goes into itself once and into 9 3 times. Other than that, let's see, if 4 goes into 68, I'm pretty sure that it does. I'll work it out here on the side to make sure. 4 goes into 6 1 time. 4 goes into 28 7 times. So 4 goes into itself once. It goes into 68 17 times. Now I'm left with 1 and a 1 and a 17, a 1 and a 1 and a 3. So 1 times 1 times 17 would be 17. 1 times 1 times 3 is just 3. And that would be the final answer, unless, of course, we wanted to change it from a reduced fraction to a mixed number. Now let me back up just a minute. When you're multiplying fractions like this, you could always go 81 times 4 times 68. That would be a big number, but you could do that, and then 16 times 27 times 9 and figure out that large number. But it's easier if you do the simplifying first, because then you don't have to do quite as much computational problems. If we want to change this then to a mixed number, we would take 17 and divide it by 3. It goes in 5 times with a remainder of 2. That means that a negative 17/3 is the same as a negative 5. The remainder gives us our numerator, and the 3 then becomes the denominator. So the solution to the problem then is negative 17/3, or as a mixed number, we could write it as negative 5 2/3. Let me review just a little bit. When we work with these mixed number problems, we can change the mixed numbers to fractions. And when we divide, we multiply by the reciprocal. When I got to this step, I figured out whether the answer was positive or negative, and then did the simplification that I could with the fraction to come up with the answer. And then sometimes we want them written as a mixed number, depending on what the problem is asking for or what your teacher wants. I hope that helps some of you, and we encourage you to call Math Helps tonight. We're going to put the camera on our brain teaser again, I think, so that you have a chance to read the brain teaser.
For those of you that are just tuning in, we have started the program with a brain teaser, and you can see the number 752-1811. It's takeoff of last night's brain teaser, but the question that is being asked: what is the prime factorization of 7,521,811? So you will leave that on for the next 30 minutes and let you have an opportunity to work at it. So for those of you that are just tuning in, the brain teaser is already on the board. We started early in the program, and you may call in. We hope that you can solve the brain teaser and receive a handheld calculator. We'll now go to Mrs. Nichols. She has the next problem, and we'll move to her at this time.
Okay, I'm going to do another problem similar to one that was done before, showing how to change from fractions to decimals to percents, and decimals to fractions and percent to decimal and to fraction. Okay, if we have a fraction 4/5, we need to know how, and for several different operations and so forth in math, we need to know how to change a fraction to a decimal, and we need to know how to change it to a percent as well. Okay, to change any fraction to a decimal, if you have a fraction that can be changed to a denominator of 100 easily, then we've got it made. And we can do this one. 5 times what is 100? Well, it's going to be 20, isn't it? So if you multiply the denominator by 20 to get 100, we can multiply the numerator by 20 also, and that gives us 80. And if we have 80 hundredths, that's easy to write as decimal. It's 0.80. Okay? But if you have a number here that's not easily done that way, it's not easily changed to 100, you can find the decimal by dividing the denominator into the numerator. So that would be 5 into 4. Put our decimal and add a 0. Now, since we're going to deal with percent, we can take it out to 2 decimal places because percent means per 100. So 5 into 40 will go 8 times, and it goes 8 exactly. Now, so our decimal, we can write our decimal either as 0.80 or 0.8. Now, but a lot of times we'll write it with the 0 behind it when we're dealing with percents, because percent has to have 2 places in the decimal form. So, because it means per 100. So if we have 8 tenths, it's the same thing as 80 hundredths, which means 80%. In other words, you have to move your decimal point over 2 places to the right. So if you had 0.8, if we move it 2 places, we'd have to supply the 0 later on anyway. You don't have to write it at first, but sometimes it just saves some students some worry about where you get the next digit from. Okay, that's changing a fraction to a decimal and then a decimal to a percent. Okay, let's change a decimal, say if we have 0.625. How do you change a decimal to a fraction or a percent? Well, if you have your decimal, it's easy to change to a percent. All you have to do, if you remember up here, is move your decimal point 2 places to the right. So if we move our decimal 2 places over here, it gives us our percent of 62.5%. All we have to do is move a decimal point 2 places. Now, that's the easy part. Now, how do you change a decimal to a fraction? Okay, any decimal can be written with a denominator of 10, hundredths, thousandths. Okay, this is the tenths place, hundredths place, thousandths place. So if we write this number as a fraction, it's going to be 625 over 1,000. Okay, now that's the fraction. Now a lot of times they ask for the simplified fraction, so that means you need to reduce it. Now you know that you can reduce it by 5 because both of those end in either a 5 or a 0. But you also know that you can divide it by 25 because any number that ends in zeros over 100 that has all zeros, so you know you can divide by 25. If you think in terms of money, it makes it easier. Okay, how many quarters do you have in a dollar? You have 4, so 25 into 100 will go 4 times, and then you have your 0, so our denominator is going to be 40. How many quarters do you have in $6.25, if you want to think of that? Or out of $6, you have how many quarters? Okay, in each dollar you have 4 quarters, so you have 24 plus 1 more, and that's 25. Okay, now we can still do some more reducing. So this is going to come down and we'll reduce. We know we can divide by 5 again because 5 into 25 will go 5 times and 5 into 40 will go 8. So this is our common fraction right here for this decimal. Just put your decimal over the number of the place value that it ends in and then reduce it. Okay, now let's talk about changing a percent. If we have 25%, how do you change a percent to a decimal? Okay, the easiest way is to drop your percent sign and move the decimal point 2 places to the left. We're doing just the opposite of what we did when we changed a decimal to a percent. We're going to go percent to a decimal. Up here we moved our decimal point 2 places to the right and added our percent sign. Down here we're going to drop the percent sign and move our decimal 2 places to the left. So it's going to be decimal 2, 5. And once again, how do you change a decimal to a fraction or a percent to a fraction? You can go use either one of these to get to your fraction. So let's look at this. Percent means per hundred, so that means right away you can write 25. You can drop your percent sign and write a decimal or a denominator of 100 and reduce from there. Okay, and 25 into 25 will go once, and 25 into 100 will go 4 times. Or you can look at this one and say, well, that's 25 hundredths in decimal form, but in fractional form you can write it as 25 over 100, and it's going to reduce to 1/4 as well. So a lot of times knowing how to move from fraction to decimal to percent and back again in any one of those directions is extremely helpful in your computation, because sometimes, well, you never compute with things in percent form. You always have to change it either to a decimal or to a fraction. And sometimes the figuring is easier with a decimal, so you need to know how to find your decimal equivalent. Sometimes the computation is easier in the fractional form, so you need to use the fraction. So I hope that's helped those 7th graders that have had work like this as a review, and also the 6th graders and those of you who are on this concept now. Okay, Mrs. Pullman's getting ready with another problem here, so I'm going to turn.
Okay, in algebra we've been talking about, given two rational numbers, finding the one that is exactly right in the middle. So if we have the two fractions, -1/2 and -1/8, we want to find what is exactly the middle of these two rational numbers. There's a couple different ways we can work these. I'll show you 1 or 2 different ways, and I hope that helps those of you that are in my algebra that are having this on the quiz tomorrow. Okay, one way we can do this is to add these two together and then divide by 2, which is the same as multiplying by 1/2. That's taking the average. We can add the two numbers together and divide by 2 or multiply by 1/2, and that average it, and that will tell us what's exactly right in the middle of these two. In order to add these two fractions, we need a common denominator, which would be 8. -1/2 is the same as -4/8. -1/8 is, of course, just -1/8. We're still going to multiply it by 1/2. Now we take -4/8 and -1/8, and that is -5/8. We multiply that by 1/2, and we get -5/16. That means if we were to draw a number line and we had a half and a -1/2 and a -1/8, -5/16 is the midway number in between the two. Now that's one way of doing it, adding them together and dividing by 2 or multiplying by 1/2. Another way we can do it is take the smallest number plus half of the difference. Now as we think of a number line, if this right here is 0 and over here is -1, right in the middle would be -1/2, and over here somewhere would be -1/8. So the smallest one is the -1/2. Using this other method, we would take the smallest, the -1/2, and we would add half of the difference of these two numbers. Now the difference is when you take the largest, the -1/8, and subtract the smallest, the -1/2. Now we're going to have to be careful here because we have minus and negative, and we'll have to be careful with our signs. Once again, we took the smallest, that was the -1/2, and we added half the difference, -1/8 minus -1/2. Okay, let's see how we can do this one. First thing we need to do again is to work with these fractions here by finding a common denominator, and it would be 8. Well, subtracting a negative is the same as adding, so instead of having minus and negative, I'll change that to plus. 2 goes into 8 4 times, and 1 times 4 is 4/8. Okay, now we have 4/8 plus a -1/8 would be 3/8. We multiply that by 1/2, and add the negative 1/2. Okay, 3/8 times 1/2 would be 3/16. And to 3/16 we want to add a negative 1/2. In this case, in most cases, this other method here takes a little bit longer, takes a few more steps, but it's important to understand this concept if you're not looking for the number halfway in between, but if you were looking for something 1/3 of the way or 1/5 or 1/7, something like that. When you're looking for something 1/7 of the way, you can't use this over here where you add it together and you divide it by 2. You would have to do something a little bit different. Okay, let's finish this problem then. We have a negative 1/2 plus 3/16. We need to have a common denominator, which is 16. Negative 1/2 is the same as negative 8/16. If we take negative 8/16 and we add 3/16, we come up with negative 5/16, which better be what we got over here, and it is. So we get the same answer. Did you hear that truck? Get the same answer using both methods. Okay, I want to show you another one. This time we had two negative numbers and we found the one halfway in between. But let's see what happens if we're trying to find the midway point where one of them is positive and one of them is negative. Okay, let's try negative 10/3 and a positive 9/5. Okay, we want to find exactly in the middle of these two fractions. Okay, let's use the method where we add them together and divide by 2 or else multiply by 1/2. If we do, we would have negative 10/3 plus 9/5. And I think it's easier to go ahead and write it as times 1/2. We need our common denominator here. This time it looks like it would be 15 would be the least common denominator. 3 goes into 15 5 times. 5 times 10 is a negative 50. 5 goes into 15 3 times, and 3 times 9 is 27. When we get done with adding those, once again we'll multiply by 1/2. Okay, we've got negative 50 plus 27. If we take 50 and subtract 27, we come up with 23. So that would mean since the negative 50 is larger, our answer, our fraction would be a negative 23/15. When you add a positive and a negative number, it takes the sign of the largest. So the sign here is negative since the 50 is larger. Then we multiply that by 1/2 to come up with our answer. So we have negative 23 times 1 is negative 23. 15 times 2 is 30. So that's the answer. That's the fraction that's halfway in between a negative 10/3 and a positive 9/5. If you wanted to take a number line and divide it up into 30ths and mark down negative 10/3 would be negative 130ths. 9/5 would be 54/30ths, I think. And you want to divide all that out and count and divide by 2, you would end up with that right answer. But I think this is quite a bit easier. Okay, it looks like Mr. Stewart's ready to do something.
Okay, I thought we'd do a couple of problems that involve simplifying integers and powers of integers. Let me just write a couple up here. First of all, let me just give you a basic little lesson. Let's see if we can find the difference between these two expressions. Here we've got a negative 3 squared, and here we've got a negative 3 squared. But there is a little bit of difference here in that this one has parentheses around the negative 3. Now, you know, I assume a lot of you know what exponents are. When we have a little number written up and to the right of another number, it means that we're using the number down here as a factor this many times. If we didn't have any signs, if we just had a 3 to the second power, what that would mean is that we are using the number 3 as a factor 2 times, or in other words, we would have 3 times 3, which of course is equal to 9. If we had 2 to the third, that would mean that we're using this number down here as a factor this many times. So we've got 2 times 2 times 2, which 2 times 2 is 4 times 2 is 8. Okay? So that's what the exponent means. Now, let me show you what to do if you're using exponents with negative numbers. If there's an exponent here, and there are not parentheses around the number and the sign, what it means is the same as, we could spread it out a little bit and write it like that. We're going to square the 3, or in other words, use it as a factor 2 times, and whatever we get is going to have a negative in front of it. So the result of this will be 3 squared will give us 9, and we've got the negative there, so we've got a negative 9. Now, when it's got parentheses around it, as in this case, it means that we're using the whole thing here, negative 3, as a factor 2 times. So we would write that as negative 3 times negative 3. Now, if you're familiar with integers, you know that when you multiply 2 negative integers together, the answer will turn out positive. 3 times 3 is 9, and the negative times the negative, or the 2 negatives, will turn into a positive. So the answer here will be a positive 9. So there is a difference then between negative 3 to the second power written in this form and a negative 3 with parentheses around it to the second power. Now, I took this problem out of an algebra book, and let me actually write the problem as it appeared in the algebra book. Here it is. We had a negative 3 to the second power minus a negative 3 quantity squared. So let's see if we can simplify that. Again, we know that the negative does not attach to the 3. Okay, we go ahead and square the 3, or take it to the second power first, and then put the negative onto the result. So we've got here 3 times 3 is 9 again, so it's negative 9. Now we can bring this minus down and go ahead and do this one out. And again, when we multiply negative 3 times itself, negative 3 times negative 3, we end up with a positive 9. So what we've got here is a negative 9 minus a positive 9. Now, double signs are sometimes confusing, and I have found that the way that makes it the least confusing for me is to always convert double signs into single signs. Whenever we have 2 signs in front of one number, we could read that as the opposite of positive 9. Okay, just looking at this much of it. The opposite of positive 9, we can always call a negative an opposite. So if we've got the opposite of positive 9, we know that the opposite of positive 9 is simply negative 9. So rather than have the double sign here, let's just go ahead and convert that double sign, the positive and the negative, into a simple negative 9. So now we've got a negative 9 and another negative 9. And if we did that on a number line, if this is 0 and we come over here a certain amount to a negative 9, then there's the first number. We could put that right there. And then we're going to go another negative 9. So we go 9 more in the negative direction. So the result here would be negative 18. And I like to think of it whenever I've got 2 negative numbers, or whenever I've got 2 positive numbers, I simply add the 2 numbers together and use the sign that they have. So since we've got 2 numbers that have the same sign, we add them up. 9 plus 9 is 18, and we use the sign that they had in common. So this expression right here would simplify to a negative 18. Now let me write one more up here that's a little bit more complicated than that, and see if we can follow it through. Let's go with the 2 to the third power minus 3 squared times the quantity 2 squared minus 1 times 3 minus 2 squared. And let's put that all over 2 times 3 squared minus 2 to the third. Okay, we've got several operations here. We've obviously got subtraction, we've got multiplication, and we've also got division, since we've got a numerator and a denominator here of this expanded fraction. So let's go ahead and start to simplify. And the way that I would probably approach this would be to simplify the top and then to simplify the bottom. So let's just start right here. 2 to the third power, we know, is 2 times 2 times 2, which gives us 8. We can bring this minus down. We can't subtract a 3 from it or a 3 squared from it, because this 3 has to first be multiplied by all of that before we put the negative there. So let's just put the negative there and hold off on our subtraction until we get this stuff taken care of. So right here we have a 3 squared. 3 squared means 3 times 3, which is 9. And now inside the first parenthesis, we've got a 2 squared minus 1. 2 to the second power is 4, and 4 minus 1 is 3, so that simplifies to 3. Inside this next set, we've got a 3 minus 2 squared. Again, here we would do the multiplication first, or the powers first, before we subtract. So 2 to the second power is 4, And since this negative is not inside parentheses with the 2, we need to square it first and then put the minus in front of it. So 2 to the second power is 4, so what we end up with is 3 minus 4. 3 minus 4 is a negative 1. So that's what we've got the top simplified to so far. Let's go ahead and start the bottom now. We can write the 2 down and then simplify what's inside the parentheses. 3 to the second power is 9, and 2 to the third power is 8. So we've got 9 minus 8, which is 1, of course. Okay, now let's go ahead and simplify the numerator a little bit more. We can't subtract again until we've taken care of our multiplication. So let's multiply these 3 integers together. A 9 times 3 is 27, and a 27 times a negative 1 will give us a negative 27. So that much right there simplifies to negative 27. And then we've got this 8 in front of it. So on the top we've got 8 minus 27 now. 2 times 1 is 2, so the denominator is 2. Now we've got 8 minus 27. We can think of this as a positive 8 and this is a negative 27. So since the signs are different, we need to subtract the 2 of them. If we subtract 8 from 27, we will get 19. And we'll use the negative sign since the negative was the bigger integer there. So we've got the top simplifying to negative 19. The bottom again was 2. And to finish our problem then, we would divide 2 into 19. 2 into negative 19. We'll get a negative in front of it. And 2 will go into 19 9 1/2 times. So the answer to this problem would be a negative 9 1/2. So I hope that provided a little bit of help for those of you who are simplifying problems that involve integers. Let's slide over here one more time to the brain teaser. We've had this on since about 5 after 5, and we haven't, we have had a correct answer. So we'll go on just a minute and tell you what that answer is and who is the winner. We'll slide over now to Mrs. Pullman with the next problem.
Okay. In our 6th grade math class today, in one of them, we talked about correcting mistakes. Given a story problem, we tried to see whether or not the answer was reasonable or not. I'd like to read one of them and the answer that they have given, and we'll try to decide if it's reasonable or not, and if it isn't, we'll find the right answer. It says Hiroko's backyard is rectangular. Its length is 16 meters and its width is 14 meters. So let's draw a rectangle here that's 16 by 14. Not quite in proportion, but okay, it's 16 meters by 14 meters. To use your imagination there a little bit. It says, how much fencing is needed to go around the yard? And the answer that's given in the book, that we have to decide if it makes sense or not, is that it would take 224 meters of fencing to enclose that rectangular backyard. Now, you have to keep in mind here that if you're talking about fence, that's just going to go around the outside. That means we would need 16 meters plus the 14 meters plus 16 meters up here and 14 meters over here. And if we add all those together, that's how much fencing we would need. So let's go ahead. 6 and 4 is 10, and 10 is 20, carry the 2, 10, 20, 30, 40, 50, 60. We come up with the fact that it would take 60 meters. That's how much fencing it would take to go around his backyard. So this answer would not be reasonable. The answer is no, it's not reasonable. In fact, the answer is 60 meters. I think the reason they had 224 is to see if they would confuse you a little bit by the fact that if we went 14 times 16, then we would probably come up with 224. Let's see if we do. 14 meters times 16, 4 times 6 is 24. Here the 2, 16. Carry the 1, and that's right. That's how they came up with 224. But that is not how much fencing it would take. That means that in this rectangular yard here, if we were to divide it all the way into meters, we would have 224 little squares in there. So that's 224 square meters for the area, but it certainly wouldn't take that much fencing. Let's read one more of them and see if it makes sense. The next one says, the Travelers Motor Inn has a circular pool. The diameter of the pool is 10 meters. Okay, so let's draw a pool that's circular, a circle. And then we'll finish reading the rest of the problem. Okay, so we have our circle here, and it says the diameter of the pool is 10 meters. So we draw our diameter here, and that's 10 meters. Then it says, what is the distance around the outside of the pool? Well, that would be called the circumference. And the formula for circumference is that the circumference is pi times the diameter. If we use the value for pi, approximately 3.14, and multiply it by the diameter, that should give us our answer. The answer that they have given us, that we have to see if it's reasonable or not, they said the answer was 3,140 meters. Now, if you're good at this, at reading story problems and seeing if the answers are reasonable or not, you would probably see right off that it isn't. Let's actually calculate it and find out what it actually is. The circumference is pi times the diameter, so we take 3.14 and multiply it by the diameter, which is 10 meters. Okay, 0 times 4, those will all be zeros. 1 times 4, 1 times 1, and 1 times 3. When we multiply with decimals, we move it over the same number of places. We have 2 decimal places. We move this one over 2 decimal places. And that tells us that the circumference around the outside of this pool, then the circumference is equal to 31.4 meters. So on this one, the answer is no. That is not a reasonable answer. The answer is actually 31.4 meters. Let me go through another one. Joni has only 2 2/4 cups of uncooked instant rice left in the package. She figures she needs about 1/4 cup of uncooked rice for each serving. How many people can Joni serve? Okay, let me erase this problem so we've got some room here. Okay, Joni has 2 2/4 cups of rice, and each serving needs to be 1/4 of a cup, and they want to know how many people we can serve. The answer that we are given is that will serve 10 people. Let's see if that makes sense or not. If we take 2 2/4 and divide it by 1/4, that will tell us how many people we can serve. 2 2/4, 4 times 2 is 8, and 2 is 10/4. And once again, when we divide fractions, we multiply by the reciprocal, which is 4 ones. In other words, we just switch that one upside down. Okay, the 4's would cancel, and we come up with the answer of 10. So that answer is correct. It is reasonable, and sometimes it's not real obvious. But this time we figured it out, and it is 10 people. Okay, looks like Mr. Stewart's ready for our concept now. He's got some help.
Before we go to Mr. Stewart, we would like to encourage those of you that are watching to please call 752-1811. We have a number 8 on the television set there, and for those of you that are interested in calling in, we need some more calls so we can award a handheld calculator tonight. We apologize for the video problem that is on television. We cannot correct it here. It will be corrected during the summer as Channel 13 cable TV works on the signal. So again, it is not your set, but it is a signal unique to this particular channel. I think Mr. Stewart and Tim Ross from the 8th grade at the middle school is here to help Mr. Stewart, and we appreciate Tim taking time to come in and help us with our concept. We'll turn the time now to Mr. Stewart.
Thank you. Come on over, Tim. What have you been up to?
Flying my kite.
Flying your kite. Let's take a look at that thing. Wow, that looks like a dandy. What is it?
It's a Black Hawk.
A Black Hawk, huh? I thought maybe you'd say it was your math teacher. I'm glad you didn't. That thing go pretty good out there, does it?
Yeah.
How high can you get it to go?
I don't know.
Huh. As long as you're here, Tim, let's see if we can figure out how to tell how high your kite flies, okay?
Okay.
Maybe we can set this down for a second and come over here to a smaller model. Here's our kite, and we've got it flying up there in the air, and we want to know how high it is from the kite down to the ground, okay? Now, it's a little bit difficult, I'm sure. Is that how you spell height? We hope so. Okay, it's a little bit difficult to know how high your kite is. Do you have any idea how you can figure that out, Tim?
No.
I mean, if you had a long enough ladder and somebody to hold it, you know, you could climb up there with a tape measure or something, but that probably is not a very practical way. So let's take a little look here and use a little bit of trigonometry. Have you ever had much experience with trigonometry?
No.
Okay, it's something we don't teach much in the middle school, but we do just get a little bit of a taste of it. And it's a very useful thing, and useful for things like finding how high your kite is flying. So let's take this string, and I guess it shows up a little bit on the TV. And let's see if we can figure out how to tell how high your kite is. Now, the first thing you're going to need to do, Tim, is to know how much string you've got out. About how many feet of string do you usually have on your kite when you fly it?
I guess about 200.
200 feet. Okay, let's assume then that you've measured the string, and the string on your kite is 200 feet. Okay, that's the distance from right here down to the ground. If you took a little protractor, and you probably worked with some in school, have you?
Yeah.
Okay, they're pretty little things, but you can take you can make an expanded model on a piece of cardboard or something like that. And if you made one about this size and you had your kite flying up there in the air, if you set your cardboard protractor on the ground and held the string of your kite on the ground and measured the angle, if you knew that you had 200 feet and you measured the angle with a protractor, you could tell exactly how high your kite is above the ground. So let's just try a couple of these. Have you got your math helps calculator with you, Tim?
Yeah.
Good. Okay, in order to do this, we're first going to need to know what a sine ratio is. So let me just write that. This is a trigonometric term, and what it is, if you have a right triangle, okay, that's a triangle with one right angle. If you have a right triangle, then the sine of some angle, and let's call this angle K since we're talking about kites. If we want to know the sine of this thing, it will have the ratio of whatever this side is, and let's just give it a number here, say 8. If this is 8 and this side right here were 11, then the sine would form the ratio 8/11ths, okay? So the sine of angle K would be 8 over 11. And if we wanted to work that out, go ahead and divide that out on your calculator, Tim.
0.72.
Okay, 0.72, and it goes on a little bit farther. If we took a trigonometric table here, and again, you're going to have a hard time seeing this. What it is it's got the measure of the angle and then the tangent ratio and the sine ratio and the cosine ratio. And in this case, if we found that the ratio of this side of the triangle to the hypotenuse, this side, was 0.72, we could go down the sine until we found 0.72. Go ahead and help me with this, Tim. Just take a look at this. Here's the sine. Go down until you find 0.72. It might not be exact, and in this case it isn't.
731.
Okay, we've got a 0.731 and a 0.719. So we're talking somewhere between 46 and 47 degrees.
471.
Okay? So that's about a 47-degree angle. Now, we measured this one down here. And again, let's take this and hold it over here. About what's the degree on that, Tim? What's the angle?
48.
Okay, about 48. So let's take 48 degrees. We know again that if we drew a triangle here, we could draw it all the way over to here and then down where the string was coming. Let's just hold the string over here. We know with the sine ratio that this side right here, which we'll call the height of the kite, and let's just write it as an h. This side over the hypotenuse of our right triangle here, which is 200 if we have 200 feet of string out on the kite, that will be equal to the sine of 48 degrees, okay? So look up on that chart, go ahead and look up 48 degrees and tell me what you get. Okay, the first one is the tangent, so the second one would be?
0.755.
Okay, 0.755. So if we look up the sine of the angle that we measure with our protractor, look at that angle on the trigonometric table and find that the sine of that angle is 0.755. What do you think we need to do now to find h? Have you solved some problems like this before, Tim?
Yeah. You would, wouldn't you divide h by, or times 755 by,
Okay, yeah, that's right. We're going to multiply this one by this one. So let's go ahead and multiply that out. Punch that out on your calculator. 0.755 times 200. And when we do that, we will have found how high this kite is above the ground.
right. 151.
Okay, so we found then that the kite had a height of 151 feet. Okay, now sometimes, Tim, when the wind's blowing, it goes a little higher than that. Go ahead and unstick the kite there, and let's take it up a little higher. See if we can get that to come off. Let me hold this down here on the bottom, and you put it up about how high you usually fly yours. Okay, so with a good wind, we can get a pretty good angle on that. Now let's go ahead and find out what the height is now. Again, we know that the string is 200 feet because we measured that prior to letting the kite up. We want to know what this distance right here is, okay? Straight down to the ground. So we're going to multiply, as we did before, 200 times the sine of whatever this angle is. And how many degrees do we have this time?
Probably about 69.
Okay, about 69 degrees. So go ahead and look up on the table there the sine of 69 degrees.
0.934.
0.934. So if we multiply that number that we find from the table times this number, we'll end up with the height of the kite. Go ahead and punch that out on your handy little Math Helps calculator. And we get,
186.8.
okay. So that's getting up there pretty good. How high do you think the kite would be if we flew it straight up so it was right above us?
Not sure, probably.
Probably 200 feet, huh, if we had 200 feet of string, okay?
Yeah.
So the higher that thing goes, the higher the height of the kite is until it goes straight up. If it's straight above us and we've got 200 feet of string, that is 200. When it hits the ground, obviously, it's got a height of 0. So you can tell with a protractor and your little Math Helps calculator how high your kite is flying. And I'll tell you what we're going to do. If any of you are interested, and I hope there are a few out there watching, if you would like to have a little kite height kit, just talk to me at school, at the middle school, and I'll get you a little protractor, and I'll run one off on a piece of paper so it's big enough that you can use it out there while you're flying your kite. And I'll also run off a sine table so that you can have the equipment necessary to find out exactly how high your kite is flying. So again, if you'd like some material there, just stop and talk to me at the middle school and I'll be happy to get it for you. Tim, we thank you for coming in, and hope that you'll take advantage of your new skills now and see how high the Black Hawk is up there on the ground. Okay, thanks, Tim.
While we are waiting for Mr. Stewart to put the answer on for the brain teaser, we would like to thank Tim Ross from the middle school for coming in, taking time to help us with the concept. And we appreciate the materials he brought, and I know that as you begin to fly your kite, you'll all want a kite flying kit so that you can learn how to use it and identify how high your kite is flying. So we'll go back to Mr. Stewart right now. He's ready to put the answer on the board.
Okay, here's the answer to our brain teaser tonight. The prime factorization of 7521811 is 11 times 71 times 9,631. And our winner tonight was Julia Bringhurst, who's a 7th grader in Mrs. Nichols' class. And I'm not sure just how Julia found the answer to this, but I'll tell you how I found the answer to it. It's not something that you can particularly do mathematically. What you have to do to find out what the prime factorization of this number is is just start trying all the prime numbers until you find one that will divide evenly into this number. So if you took this number, and let me just list the first several prime numbers. The first one is 2, which is the only even prime number. Then we've got 3, 5, 7, 11, 13, 17, 19, and so on. So what you'd have to do in order to tell if this, or in order to find the prime factorization of this, is just start dividing by all these prime numbers. Now we know that it's not divisible by 2 because 2 is an even number and this is not an even number. We also have a divisibility test for 3 by adding the sum of the digits together, which you noticed yesterday on the program was 25. Since 3 will not go into 25, this number is not divisible by 3. It doesn't end in a 5 or a 0, so we know it's not divisible by 5. There isn't any really easy test for 7, so you just have to punch this number into your calculator and then push divided by 7 to find out if it was divisible by 7, which it isn't, and just keep doing that. The first one we come to that it is divisible by is 11. Once we know that, then we take the quotient of 11 divided into 7521811, and we start doing the same test with it. Start dividing it by all the prime numbers until we find one again that is. So I assume that Julia probably had a table of prime numbers so that she didn't have to try every number. So anyway, this is the prime factorization of our telephone number, and maybe in your spare time tonight you might want to find the prime factorization of your own telephone number. So we appreciate Julia and her efforts to find the answer to our brain teaser tonight.
It's nearing the time for us to close the program, and as you can see on the television set, we had an 8 up there. I'm sorry that we're unable to award the calculator again tonight. We did not have the 8th caller. I'm sure that we are competing against that very fine weather, and hopefully when we come on Monday, there will be a number of students out there that will call us. We want to be able to help you with your mathematics. We appreciate Julia Bringhurst watching television tonight. She will have a handheld calculator tomorrow, and we'll send that out to the middle school. She was able to solve the brain teaser, and we appreciate her calling in. We want to thank Tim Ross for coming in. I'm sure for those of you that have watched the program, you can see how easy it is to determine the height of your kite. And each time you fly your kite, I'm sure you'll reflect back on today's lesson. You can see that math can be fun, and with a little kite flying kit, I'm sure you could figure the height of all your kites as you fly them. They just passed me a message. I have to ask what I'm supposed to do with this message. The one, oh, excuse me. I used the wrong name. It's not Tim Ross. It's Tim Morales. So I apologize to Tim for using the incorrect name. We will be on Monday night, and we'll ask those of you that are out there to get ready and call us Monday. We'd like to thank Mrs. Pullman and Mr. Stewart for tonight's very fine lesson. But also I'd like to recognize our students that help us each night. Alan Stetler, Sheila Ward, Kim Robson, and Shirley Davis. Without their help, this program would not be possible. So we hope you have a very fun weekend and enjoy yourself in the sun. We'll be back on Monday to help you with your mathematics. Thank you and good night.